Hello, everybody. This is Dr. Amrish. Today I am here with a new topic, that is a transport of oxygen, which is very important for examination point of view for UG and PG, including all paramedical courses. My request is, please subscribe my channel for further notifications and alerts so that you can't miss any of my classes. So if you like my channel, please subscribe and get the updates. So we'll go into the topic. The topic is transport of oxygen. You know, and oxygen transport is one of the um, important factors for the survival of the cells. I will explain you how this is. Carbon dioxide transport was explained in the earlier chapter. So today I'm dealing with transport of the oxygen. Very, very important. Once again, I'm telling you, I'm informing you. Every time in the body, 100 ml of the blood delivering about 5 ml of oxygen to the tissues. Okay, the statement is clear. 100 ml of the blood delivering about 5 ml of oxygen to the tissues. That means we have 5 liters of the blood. So in 5 liters of the blood, a tissue or organ and is utilized by the oxygen is about 250 ml per minute. The total oxygen delivery to the tissues would be 1 minute is at 250 ml. So oxygen transport occurs by mainly 4 headings. Number 1 is called uptake of oxygen by the lungs. Uptake of the oxygen by the lungs. Number 2 called transport in the blood. So the second method is known as transport in the blood. The third one, oxygen dissociation curve. And fourth one, delivery to the tissues. With these 4 headings, I conclude my lecture. These are very, very important headings under the transport of the oxygen. Now we'll move on to the next part. The first heading is uptake of oxygen by the lungs. Remember, the above part is, this part is alveolus, half part of the alveolus, and where you could see the partial pressure of oxygen in the alveoli is 104 mm of Hg. Each and every alveoli surrounded by the pulmonary capillary. Below there is a pulmonary capillary. The pulmonary capillary will have arterial end and also venous end. So the arterial end, the partial pressure is about 40 mm of Hg and venous end is same like that of alveolus, 104 mm of Hg. So the exchange of the transfusion or the movement of the oxygen occurs from alveolus to arterial end due to the difference of 104 mm of Hg and 40 mm of Hg, 40 mm of Hg, causing moving the oxygen from alveoli into tissues, pulmonary capillary. From pulmonary capillary, it is supplied to various parts of the body. So finally, I want to tell you very important thing is the uptake of oxygen by the lungs is a purely depending upon the partial pressure gradient, partial pressure of the oxygen, causing movement of oxygen from environment to alveoli, alveoli to pulmonary capillary, from there to other parts of the body. Okay, now we'll move on to the next part. See this one. The second heading would be transport in the blood. Okay, what is transporting in the blood? Oxygen transport in the blood. Oxygen transport in the blood occurs by 2 methods. One is a dissolved form and another one is combined form. So here dissolved form for arterial blood, venous blood and the difference, and also total content of oxygen carried by dissolved form, combined form, even total oxygen transported in dissolved form, combined form, and a difference, how much it could be, all were very clearly mentioned. And I take for arterial blood 0.3 ml of oxygen per minute is transported in dissolved form in arterial blood. That means out of the 100 percentage, 3 percentage, very minimal percentage of the oxygen is transported by the dissolved form, and the remaining is in combination with hemoglobin. The dissolved form, remember, the oxygen dissolves in the plasma, and in dissolving in the plasma, transporting as a physical solution the 3 percentage. The remaining percentage of oxygen transported 97%, about 97 percentage is transported by the what do you call your it could be in the combined form I said you. So we'll see how in combined form it is transported in combination with hemoglobin. It is the combining of hemoglobin with oxygen is a oxygenation. The process is called oxygenation. It is not the oxidation. Here are some of the steps were given, mentioned. Hb4O2 gives rise to Hb4 plus O2, Hb4O2. To that Hb4O2, one oxygen is added, Hb4O4, then Hb4O6, then Hb4O8. This means one oxygen molecule can combine with 4 oxygen molecules can combine with one hemoglobin. Okay, one hemoglobin. See, now we'll see the oxygen carrying capacity. One molecule of hemoglobin carries 4 molecules of the oxygen. That means 1 gram of hemoglobin carries 1.34 ml of oxygen. This is very important Viva question and also multiple choice question. In the body, 15 grams in an average, 15 grams of hemoglobin per 100 ml of the blood carrying 1.34 into 15 is equal to 20 ml of oxygen is transported in our body. This is called oxygen carrying capacity of the blood. Now, the oxygen carrying capacity can be better explained by a curve called, the name of the curve is oxygen dissociation curve. So, the oxygen dissociation curve, a curve is obtained by plotting the relationship between a partial pressure of oxygen on x-axis in mm of Hg and a percentage of the saturation, oxygen saturation in the hemoglobin. Hemoglobin is called ODC curve. ODC curve. If you see the features of the ODC curve, the curve resembles like S-shaped or sigmoid shaped. The curve, the middle one is the normal curve. Here is a normal one. This is a normal curve. And sometimes the curve may shift towards right. Sometimes the curve may shift towards left also. So, here the curve will have 2 zones mainly. One of the zone, this is called, we divided the curve into 2 zones, the upper zone and lower zone. The upper zone is called plateau. This is known as a plateau or loading zone. We can call it as loading zone or plateau. The process of uptake of oxygen in the lungs is indicated by this zone, and at the partial pressure of 100 mm of Hg, the percentage of the saturation would be 97 only, and complete saturation, 100% of the saturation will not be present. Okay, that is one of the point to be remembered. This is about loading zone. Coming to the unloading zone or a steep phase, this is known as a steep phase, where in the steep phase is observed around 60 of Hg. It is concerned with the oxygen delivery to the tissues at the partial pressure of 40 of Hg, at the partial pressure of 40 of Hg. That means here at the 40 of Hg. And one more thing, the partial pressure of 40 of Hg, the percentage of the saturation would be just 75 percentage only. 75 percentage. 40 partial pressure of oxygen, percentage of the saturation would be 75, which is called unloading zone, steep phase, and the above one is called loading zone or plateau. The another one is, I can tell you, around 27 of Hg, you could see the percentage of the saturation is the 50 percentage, is known as P50, which has got more impact over the steep phase. And I would like to mention one thing. If the P50 increases, the curve shifting towards right. That means, and if the P50 value goes beyond P50, the curve is shifting towards right, and the P50 value is less, the curve shifting towards left side. So these are the points to be noted. And now I can tell you what is the significance of studying about the curve. With the curve, it allows greater uptake of the oxygen in the lungs in spite of variation in the alveolar partial pressure. That means tissues are supplied enough with the oxygen according to the needs of the demand by the tissues. And also here hemoglobin acts like a buffer for oxygen maintenance in the tissues with the partial pressure of 40 of Hg. Though it is 40 of Hg, hemoglobin acting like a buffer for the oxygen and maintaining the tissue PO2 at even 40 of Hg. These are some of the advantages of the ODC curve. In the beginning, I said the curve may shift towards right or it may shift towards left also. What are the factors? The curve shifting towards right are, and one is called the increased PCO2, and one more called hypoxia is one factor is there, and a decrease in the pH is there, increase in the temperature is there, increase in the 2,3-DPG are there. Under these all factors, the curve is shifting towards right. The red line indicates the curve shifting towards right. Now, the curve shifts towards right means it is indicating that, and it is loading the oxygen to the tissues. Availability of the oxygen to the tissues would be more when the curve is shifting towards right. And here I mentioned increased PCO2 is called Bohr effect. What is the meaning of the Bohr effect? I will explain the Bohr effect in the coming slide. And increased partial pressure of carbon dioxide causing its unload and loading of the oxygen occurs. That means oxygen is loaded to the hemoglobin, loaded in the hemoglobin, and carbon dioxide is unloaded and at the lungs and sent out from the body is known as Bohr effect. So these are the factors where the curve is shifting towards right. One more factor, during exercise even the curve is shifting towards right. So during exercise, what happens is, and metabolic activity, metabolic rate increases, then increased temperature in the muscle causes these two factors causes the curve to shift towards right. The curve is shifting towards right. I have told you again, and hence your however your oxygen, this one, the curve is shifting towards right, means it is a loading of the oxygen to the tissue according to the demand by the body, demand by the tissue occurs. Now some of the factors where the curve is shifting towards right, you can see decreased PCO2, almost the reverse changes to the shifting of the right. Next, increase in the pH is another factor, decrease in the temperature, decrease in the 2,3-DPG, 2,3-DPG. Then fetal hemoglobin is another factor, carbon monoxide poisoning. Fetal hemoglobin has got more affinity towards oxygen. Even carbon monoxide is having more affinity than oxygen. That's why these factors are shifting the curve towards left. So these all, I mean, these are the ODC curve is very, very important. We have learnt the normal features of the curve. What is the definition of the curve, and then what is P50, and what factors converting, I mean shifting the curve towards right and curve towards left, all we have seen. Now we'll see the Bohr effect. This is very, very important in oxygen transport. Without Bohr effect, we cannot conclude the topic at all. Remember, increased PCO2, particularly talking about the PCO2 effect on the ODC curve, causing unloading of the oxygen, and from the blood, which causes loading of the unloading of the oxygen from the blood and loading of the carbon dioxide. So unloading of the oxygen, loading of the carbon dioxide. At the tissue I am talking, where at the level of the tissue, unloading of the oxygen to the tissues from the hemoglobin, loading of the CO2 at the tissue into the hemoglobin is called causing the curve to shift towards the right side is known as a Bohr effect. That's why I said increased carbon dioxide effect on the ODC curve is called Bohr effect, which helps the significance of the curve always would be helping of continuous supply of oxygen to the tissues and continuous removal of carbon dioxide from the tissues is the significance of the Bohr effect. With this, I conclude my lecture, short lecture on the what is called your transport of the oxygen.